Hi everyone, welcome to Last Minute Maths, and in this video I'm going to run through the paper 2 from November 2021, and it's a higher tier, the calculator paper. And just before we begin, just to mention, I'm going to try and run through this one very quickly, a little faster than my previous video, because life's too short, and I don't want us all spending our entire life watching math solution videos, all right? And also, if you find it of some use to you, please do consider subscribing and clicking on the notifications. I will be launching a couple more maths papers and also a couple of physics papers for the upcoming exam and explanation notes, etc. So that might be of some interest. All right, with that said and done, let's get down to work. Right, first one, nice and simple. It's number line, and what they're showing is that this is hollow. That means it can't equate the number, but must be on one side of it. So effectively, it's x is greater than minus 1, not equal to, but greater than only. All right. Second one, y is greater than or equal to, so that means it can include the minus 3, but less than 4, so it can't include the 4. So above the minus 3, it's a solid, and above the 4, a hollow. All right, fairly simple. Right, running on. This is similar to the last paper 2 that I covered. In fact, it's actually got the same numbers, exactly the same numbers. So again, a factor tree, and you get your 60 in prime factors, so 2 times 2 times 3 times 5, and 84 is 2 times 2 times 3 times 7. So the highest common factor is made up by multiplying the factors that appear in both. All right. I don't think you need to say too much more about that. So that's basically those 3 there and those 3 there. All right. So that's 12 in the end. 2 times 2 times 3 that appear in both numbers. Okay, the next one. Lowest common multiple, as I think I said in my previous video, is the highest common factor of these two numbers and then times all the other unused factors. All right. So for example, 24 is 2 times 2 times 2 times 3, and 40 is 2 times 2 times 2 times 5. So the common are the 2 times 2 times 2. All right, so that goes there. That's basically your highest common factor. And then the ones that are unused are the 3 and the 5. All right, so multiply those on as well, gives you 120. Very quickly, the other method that is acceptable to the examiner, if you don't want to go to all that palaver, then very simply, just do multiples. All right, you've got to do enough to show that you're getting to the exact number that you want. There we go. And 80. There we are. Could be as simple as that, as long as you don't make any mistakes with it. Right, next one, distance time graph. First thing it says, first 15 minutes in kilometers per hour. Yeah, watch out for that. All right. So what they've done is given you a graph and you're interested in that portion of it there. All right. So speed is distance over time, as we know. And the distance traveled is 20. And the time is, I think they said first 15 minutes or 10, 15. So 15 minutes that way. All right. So you've got to convert the 15 over here into hours. So it's a quarter of an hour. So 20 divided by a quarter is the same as 20 times 4. All right. If you remember fractions, if you divide by fractions, flip it upside down and times it. All right. So that gives you 80 there. All right. Nice and simple. And the next part of it, it says at that point, stops for 10 minutes and then drives for 20 minutes at a speed of 75 kilometers per hour. So the working unit to show here, if you can, it's 20 minutes equals 1/3 of an hour. All right. Therefore, the distance must be 1/3 times 75. All right. Now, I think I remember the score sheet saying that you don't actually have to show the calculation as long as it's implied in the graph. So there you are. That is your plus 25 kilometers on top of what you had. So it goes up to 45. All right. And the time, again, is 10:25 to 10:45, 20 minutes. All right. Plus the 10 that you had there. Right. That should be fairly simple. Next one, just one example. It's a quadratic. Okay. And with the 0.1, put the numbers in. So x equals 0.1, put it into the equation. -1 squared minus 2 times -1 plus 2. Taking into account all the signs, be careful about the signs, all right? 1 plus 2 plus 2, okay? 5 and so on. So the rest of them do exactly the same way. And in the graph itself, right, you want to show y equals 4 as a flat line. And I think it's worth mentioning here. Y equals 4 is a horizontal line, yeah? And just estimate the intersections that you have. Looking at it on the screen as I'm recording it, I'm getting it to be minus 0.7 and plus 2.7. All right. And I'm sure in the mark scheme they give some sort of a range that you can be within reasonable error. But when you're doing this in a real paper, use a sharp pencil. I have known in examinations a blunt pencil actually making a line thick enough so you get an answer that is not acceptable to the examiner. So please use a sharp pencil. Right, next question. It's a right angle triangle, Pythagoras, straight off. All right. Now, what they've given is a shape made up of two of these, all right, identical triangles. So first thing we need to do is to work out the diagonal, the hypotenuse of the original triangle. And as you know, it's 8 squared plus 10 squared. It's total 164. So x is 2 root 41. Put it in your calculator and you get 12.806. Hold on to the decimal places for the moment until we finish the calculation. And now to find out the total perimeter of the shape, you've got these straight edges, 8 each. So 8 plus 8 plus the 10 plus plus this diagonal here, all right, and then this extra bit. Now remember, the entire diagonal there is 806, and then the base of the triangle is 10. So this bit here must be the 12.806, if I can say it right this time, minus the 10. So 2.806, all right? So the perimeter, total perimeter, 8 plus 8 plus 10 plus 12.806, all right? And I'm going to write that in here, actually, 12.806, and plus the 2.806. Altogether, 41.612, etc. But they want three significant figures, don't forget that. And the answer is simply 41.6. All right. Right, number 6. Again, another right angle triangle, this time SOHCAHTOA. All right. And for the angle, the 56 that we have here, this is the opposite side. That's the adjacent. And this is the hypotenuse. All right. So in this case, because we know the adjacent and we want to find the opposite, the one that links the opposite and the adjacent is tan. Yeah, op over adjacent. All right, so throwing the number straight in, it works out best if you write it out this way first and then rework it. Tan 56 equals BC, the one that we're after, divided by 12, which is the adjacent. And so BC equals 12 times, so you just move the 12 over here, and 12 times tan 56 is 17.79 to one decimal place, therefore 17.8. All right. And very similar question this time, we want to find the angle when we're given two sides. In this case, we've got the adjacent and the hypotenuse. Referring to our SOHCAHTOA again, that one is effectively cos, because we have our adjacent over the hypotenuse, all right? And to use the inverse cos function of 5 over 6, which is 15 over 18, 33.557, again, one decimal place, so 33.6, all right? Okay, number 7, you've got a couple of different liquids with different densities being mixed in a certain way to make a third liquid, which is the mixture, and you have to work out the overall density of liquid C, right? First thing to remember is that mass equals density times volume, or if you like, density is mass over volume, if you remember those triangle type things. Okay, so put that in the corner somewhere, write it out, whatever helps you, but bear that in mind as you work it. Whenever you have these combination questions, so in combination of liquids or materials, even solids, yeah, find totals first. Okay, so the mass of each part. Okay, so liquid A, you've got 80 cubic centimeters, so there's your volume, and the density, 1.8, gives you a total of 144 grams. B is 40 cubic centimeters times 1.2, right, the density, and that gives us 48 grams, all right? And together, therefore, the 120 cubic centimeters of liquid C has a total mass of 192 grams, all right? So the density of C is the total mass over the total volume. And so 192 over 120 comes out to be exactly 1.6. All right. And a frequency table. Okay, 50 people solving a puzzle, and it takes a certain amount of time. And the frequency table is shown between 0 and 10, you've got 5 people. Between 10 and 20, you've got 8, and so on, all the way down. All right. The question is that they're asked to create a cumulative frequency table. So cumulative frequency table means all the data or frequency up to the stated limit. Meaning, for example, less than 30 minutes. Yeah. So how many people finished it in less than 30 minutes? It's the total. All right. So in that case, you'd have, for example, 5 plus 8 plus 12, it's 25, just as an example. That's what the cumulative means. Now, in this cumulative table that this Brian chap drew, what you have, they've kept the time categories as they were before, but they've added these up correctly. So all of this is correct, this side, but this is not, because each of those should start from 0. All right, as you can see, so that one should be from 0 each time. Okay, and that's exactly what we've written. The time column should show time starting from 0 in each case. All right, for example, that 0 to 20, and so on. That's all you need to write. It's only 1 mark, no need to overwork it, but it's worth understanding the principle of a cumulative frequency chart. Okay, this next one. Length of time waiting in a hospital on a Monday, all right? And it says work out the interquartile range. The interquartile range is the difference between the lower quartile, and this part of the box is the upper quartile, and that is the interquartile range, IQR we're going to call it, all right? And if you actually follow the chart, I mean the way the boxes are worked, please be careful, all right? Each of those, that there is actually 20, all right? That means one little box, okay, that's 5, right? 5 of them in a 20, so that's each of those is 4. So you've got to be very careful how you count this and don't get confused. For example, going along here, you know, don't make the mistake of going, oh, 165, it's 167. It's not, all right? It's actually 188 here, all right? And this one's fairly simple. That's 50, bang in the middle between the two. So the interquartile range is 188 minus 50. Oops, have I written something down wrong here? My apologies. What have I done? There we go. I think there was a incorrect writing there. So that should read as 138. There you go. All right. Don't know what I had 124 there for. Right, and then Becky says 50% of the people waited for at least 2 hours. Okay. Is she right? Very simply, yes, because the median is at 120 minutes, which is 2 hours. All right. So half the people, right, the meaning of a median is that half the people there waited longer than 2 hours. Okay. Right, that's 1 mark, nice and simple, over and done with. This next one is, I think, so unfair on students. I mean, look at that, all of that question, all that information for just 1 mark, all right? So there you go. If you feel that's a little tough, it is. It's just a waste of time. But get it done quickly. Becky asked to compare distribution of the length of time people waited on Monday compared to Tuesday. All right, so the Monday one was in the previous part of the question. This is now Tuesday. Okay, and you can pick up some information straight away. Median was 100 as opposed to 138. I think it was 138. Yep, 138. And the range 190, so from there to there. And the interquartile range was 90. And that's 190. There we go. Yeah, right. And it says people had to wait longer on Tuesday than on Monday. All right. One reason why she may be wrong. Okay. Very simply, median was lower. All right. The median was lower. So that means, 50% of the people actually waited a shorter amount of time than on Monday. So it doesn't tell you about the rest of the distribution, but this is all you need to say. You don't need to say anything more than that. Right, now here we start getting into the slightly tougher questions. Okay, in a previous video, I went through the compound method. All right, and I'm not going to sort of harp on about it. At this stage, it should be fairly evident. The compound rule for interest is that you start with your principal value and you times it by 1 plus the rate right, the interest rate in decimal form, and then this is to the power the number of periods, whether it's months or years. So in this case, it's years, all right? And the interest rate they're talking about for the first investment is 2.5% per annum. Okay, now let me explain the actual difficult part of the question. The question doesn't tell you how much is invested, it's X, all right? X. So they're both investing the same amount, X pounds, and one of them puts it in better investments, one of them puts it in the county bank, right? Both of them for 3 years. Now, in the first case, better investments, you're getting 2.5 per annum, so per year for 3 years. So the rate is 1 plus 0.025, 1.025, all right? That's your multiplier. So what information they give us is that Louise's investment, i.e. better investments, whatever that is, bank or something, that one is your principal amount X times the 1.025 to the power 3, all right? And that, they tell us, comes out as 344,605, all right? So we can use that information, reworking that, to find out what the initial investment was, all right? Because without this, we can't do the second part. Need this for Sadiq's calculation. Okay, all right. So simply dividing 344,605 with 1.025 cubed gives us the initial investment of 320,000. Nice clean number. All right. We can now use that as being the investment made by Sadiq. All right. Now the twist in this part of the question, watch out, is that in County Bank, the first 2 years is 2%. And then the final year, it's 3.5%. All right. So using the same principle as the first part of the question, we have 1.02 squared for 2 years, and then times again by 1.035. Okay. So that one was your 2%, and this one is your 3.5%. Okay. And sticking that in your calculator, you get 344,580. All right. Again, nice clean number. So please do watch out for, working backwards to find the original amount and making sure you get the powers right, squares and cubes, etc., depending on how many years. Okay. This one, I think, is actually trickier than people might think. It's a little bit messy, all right? So what we have in basic form is a straight line. You've got a point P, a point Q, and a point R, all right? They've told us that the ratio of Q to R, that bit, to that bit, as I put here, 2 to 3. So you could also look at it as being the total ratio of P to R is 5 to 2 between P and Q, all right? It all sounds a little confusing, but the diagram should help, okay? We're given coordinates of P and Q, and we want to find out what R is, the coordinates of R, all right? Now, first of all, find how far you move across to go from P to Q. So that's the X movement is 6, right? You're going from -6 to 0, okay? And then the Y movement, i.e. how far you're going up, is 3, from 0 to 3, all right? Now, the way I'm going to do it is that whatever movement I did from P to Q, I want to do the same type of movement from Q to R, but using the ratios. So what I've done is divided P to Q by 2. So 6 divided by 2, and then times by 3, because my ratio is 2 to 3, all right? So divided by 2, times it by 3. and that gives me 9. All right. Yeah, that's fine. And the y movement is a little messier. Again, divide by 2 times by 3 gives me 4.5. All right. If you then add that onto q, okay, add to q, you'll get 0 plus 9. All right, so that's 9 there. And y equals 3 plus 4.5, 7.5 there. All right. So it's applying the ratio. Watch out for this ratio here. That's the most important thing. Can also be done if you start from p and then add 5 over 2, the ratio 5 over 2. Okay, but I don't want to confuse it further. I think what I've shown you there is probably sufficient. And then it says, find an equation of the line that is perpendicular to L and passes through Q. All right. The gradient of the line we already have is half. It's 3 over 6. All right. Using the triangle, if you see from P to Q. So I'm going to put that in. From P to Q. All right. Gradient is a half. The perpendicular gradient, remember, it's take your original gradient, flip upside down, and change sign, reverse the sign. All right. So minus 1 over half comes out to be minus 2. So the first impression we have of the line is it's y equals minus 2x plus c. And because it crosses the y-axis at q, the coordinates of q are 0, 3, then straight away the y-intercept is 3. All right? So don't need to do much more than that. Okay. This one, yeah, 3 marks. It's not actually difficult mathematically. Just make sure you don't lose any terms as you go along. All right, first bit, expanding 2 brackets, right, like that. Self-evident. X times 3x, so 3x squared, minus 6x, then plus 2x, and minus 4. All right, simplifies to that. Then multiply those 2 parts again. And again, just working through and multiplying that, and then, oh God, how am I going to do this? That, and then that, and then that, and then that, and that, etc. You get the idea, all right? And all of that, if you've done the arithmetic right, comes out. Just make sure you collect all the x squareds together, the x's together, and tidy that up. That's what it means by simplify. Okay, answer is 6x cubed plus x squared minus 20x minus 12. All right, okay. This next one, I think, is a bizarre question, really strange. I don't quite understand what the point of this particular question is, but again, there you go, that's Edexcel for you. In their wisdom, it's worth remembering that this is called a counting method. Right? So basically, you're going to choose a teacher, 1 girl and 1 boy to represent the school, and you've got a choice of 16 teachers. And this 220 here, 220 students, is actually irrelevant, because what you need is that there are 120 girls and 100 boys. All right? So a choice of 16 teachers, 120 girls and 100, so you multiply them. All right? And the answer simply is that, 192,000. It's exactly the same as the menu questions. Starter, main course, dessert, etc. Okay, nothing new there. All right, this next one is worth discussing. Okay, 4 points on a circle. Now this is really important. Those 4 points of that quadrilateral, all right, are all on the circumference of the circle. All right, and this thing is a tangent. All right. And you've got a 20-degree angle here. All right. Okay. They're saying the size of BAD, so that one there, is 3 times the size of BCD, which is there. All right. So all I've done is labeled this one X, therefore that one must be 3X, all right, as I've put in the diagram itself. Okay, now the rule, oh, by the way, we want to find angle SBA, this one here, all right, that's the one that we're after. So working our way through the diagram, first of all, we know it's a cyclic quadrilateral, all right, all four, that's what I meant by all four corners, vertices of the quadrilateral rest on the circumference. So it's a cyclic quadrilateral, and the opposite angles add up to 180. Okay, so using that rule, we know that BAD plus BCD, which I've labeled as 3x and x, therefore 4x must equal 180. So x equals 45. All right, and then we know that angle BDA, which is this one here, okay, because that's in a triangle. BDA is 180 minus the 20 that we already see in the diagram, okay, minus 3x. Now we know that 3x equals 1, oh, have I done this right? 135. Yep, all right. So 180 minus 155 is 25. And the reason is angles in a triangle. That's all you need to say for that one. And so coming back to our diagram for a moment, we know that this one is 25 now, okay? And using the alternate angle theorem, or alternate segment theorem, my apologies, alternate segment theorem, remember that this angle, if you have a tangent touching a circle with a triangle inside the circle, the exterior angle there equals that opposite angle there, all right? If it's something you're not sure on, then please do go back and revise or drop it in the comments, and maybe I'll do a separate video, short video, 5-6 minutes on circle theorems, all right? So if we know that that angle is 25 inside, then this must also be the same, all right? Therefore, the answer is 25, okay? All right. And this one, number 15, triangle ABC. You know two sides, and you know the angle between, all right? So it's a straightforward application of the cos rule. I'm not sure we want to waste too much time on this, so just put the numbers in. There's your cos rule just for reminding you. And so BC squared, 8 squared, 11 squared, and then minus 2 BC, and then cos 72, all right? Work your way through all of that. And watch out, it says 3 significant figures, so that's where you want to cut it, 11.4, all right? Okay, find the area of triangle ABC. Now this time, again, using the area rule, if you know two sides and you know the angle in between, you can use the area sine rule, which is that, again, to remind you, and that's going to be half times 8 times 11 times sine 72, all right? This time it's sine, not cos. Be careful about that. And again, 3 SF, so there's your answer, 41.8, all right? Okay, now this, iteration questions, I know causes a lot of problems for people, okay? All it's saying, right, if you look at this xn, and this one's xn plus 1, means if you have a value to start with, your next value is based on whatever the previous value was. So in other words, if I have, x1, I can use it to get to x2. Once I've got x2, I put it back in the formula to get x3, and so on. I mean, I could go on if I wanted, all right? And so the formula helps get the next number by knowing the previous one. So in this case, we're starting with x0 is 2, all right? So that's where x0 goes in, and that gives us x1. So 10 minus 2 times 2, 4, so 6, and it's a cube root of 6, and there you have it, 1.817, etc. All right. If you leave that in your calculator, that then goes in here. All right. So this is x1, and it goes in here, and that helps us find x2. Okay. Again, going through the same process, we get an answer of 1.8533, etc. All right. And that is your x2, which in turn goes into here and leads us to x3. All right, so that's what iteration means. You keep getting a new number, put it back into the formula, get another new number, and just keep going, repeating. All right, so that's the iteration process. Again, if anybody is interested in more detail on that, then please drop me a comment. I'll do a video, and should only take a few minutes to do if you need it. All right, and finally we end up with x3 is that number there. Now, in this particular case, as always, I think because if we round these numbers too early, it comes out to be 1.82, 1.85, and 1.85. It's better actually to keep them to 3dp. And that way the number is actually kept distinct. All right. So that's what I've done. I've gone with 1.817, 1.853, and 1.846. All right. If you went with 2dp, which effectively is 3SF, you'd get away with that as well. Right, now this next bit is a little trickier to understand. If you do remember the iteration method actually the starting formula that we used in the previous part of the question, it comes from rearranging whatever original equation you're trying to solve. All right, so this is the formula that we started with further up in the question. And so if we get rid of the cube and rearrange it, okay, to get it back to its original form, you cube both sides, so the cube root disappears and the x on this side is cubed, so you've got x cubed equals 10 minus 2x, right, getting rid of all those ends and things. And rearranging that, look at what you have here. It's a cubic. All right, and the coefficients, therefore, a equals 2 and b equals minus 2. So that one there and that one there. All right, worth looking at that again in the books if you need any further clarification. All right, histograms. Remember, a histogram is different from a bar chart, etc., because it shows the frequency density, not the frequency. Frequency is given area. It's given by the area, all right? So if we actually do work out the area, they don't tell us how many people there were altogether. Look, it says some people, all right? So we need to work out the total number of people first, because they say 20% of the people got a score high enough for them to qualify. 20% of what? We don't know. So we need to work out what the total number of people was first. This first one here, right, it's got a height of 0.8 times a width of 5 equals 4. All right, so the frequency is 4. Same method for the next one. It's 1.6 times 10, 2.2 times 10, 22 for that one. The last box is actually 1.2 times 15, all right, equals 18. So the total for the box is 18, all right? Therefore, the total number of people is 60, right? 4 plus 16 plus 22 plus 18, total of 60. 20% of them qualified. So 20% of 60 is 12 people qualified, all right? We assume it's a top 12, all right? It's not going to be some random 12 in the middle. it's got to be the top 12 that qualified. Okay, so the top 12 must be represented by this shading here. All right, so we need to work out at what sort of mark, right, we're effectively left with 12 in the upper box there. So what I've done is taken that 1.2 we know is the height of this box. So 1.2 times a certain length, which is your score range, this bit here, equals 12. So the score range must be 10. All right. So in other words, it's 10 marks, right, or whatever the score is, 10 out of the 40, right? So over here, and therefore 40 minus the 10, the qualifying mark was 30. All right. Take a moment. If you're not sure about what I've done there, do pause the video and take a look at the diagram. Take a bit more time to understand the logic of what's going on there. All right. Okay. Right. Trig graph, next one. And they've given you a sine graph, fairly standard, 0 to 360. And then they've said, well, look, there's sine x, yeah, a certain angle, the sine of which equals 0.6. So use the graph, it says, all right? So there's 0.6, okay? Now, problem is, I'm not using a sharp pencil, I'm using one of these screen pens, all right? And what you would do in the actual exam, sharp line at 0.6 straight across the graph and see where it intercepts, all right? Now, I'm taking it roughly somewhere between, 36 and 38, okay, from what I can see there. So that's 37, and it has to be 37 in from the 180 because it's symmetrical about the middle. So that's 143. So we have those first two, all right? And to find the solutions, look at this, pay attention to this. Don't miss the fact that it's up to 720, not just 360. So that means you have to carry on the graph, right? Like that. And there's going to be two more solutions there, okay? All you're doing is repeating everything 360 degrees later. So that means you add 360 to each solution, all right? So 37 plus 360, 397, and 143 plus 360, 503, all right? Double check with calculator. In case you're not sure about the value you've read off the graph, if you might be too high, too low, double check just to be sure of what you're reading off the graph, all right? You're perfectly well allowed to do that. You've got a calculator available. There's no rule against it, but you must show it on the graph in any case. Okay, the next thing, you've got a y equals sine x, and you're reflecting in the x-axis. Those of you who remember your graph transformations, your f of x goes to f of minus x for a reflection in the y-axis, all right? So that's that one there. And so your y equals sine of x becomes sine of minus x, all right? You can write it like that, that's fine. Or you can bring the minus out. If you're confident of your trig graphs, then you can do that, and that's also valid, all right? Whichever one. Both of those forms are exactly the same, have the same meaning. And next graph transformation, y, given that you've got the original one in black, and then you're moving it to f of x minus 2, all right? When you have that, x minus 2, it actually moves to the right, okay? Not in the negative direction. It moves in the opposite direction, the positive direction. So it moves right 2 units, and then you just redraw the graph, so this is the one that you're after as your answer. 1 mark only for that. Right, here's what I think is a tricky question, a genuinely tricky question, all right? You've got a volume of a sphere, A, is 125, and volume of sphere B is 27 cubic centimeters, all right? I'll put the volume formula there. It is in part available to you when you need it in a question. In this case, you don't really need it, but it's worth having it there. This question is all about scale factors for lengths areas, and volumes. Just to remind you, a simple length ratio is a scale factor. All right, that's that one. Given a certain scale factor of lengths, the area ratio will be that scale factor squared. Okay, and the volume ratio is going to be the scale factor cubed. Now that's very, very important to remember. All right, so what we have now is the volume of A to the volume of B has a ratio of 125 to 27, okay, which I'm just putting in the actual volume formulas here, just to show you where that came from. So what you actually have is this: 125 over 27 is the radius of A cubed divided by the radius of B cubed, all right? And so if you cube root both sides like this, then you end up with this. 5 over 3 equals a ratio of radius of A over radius of B, all right? And we get a statement like that, all right? So the radius of A is 5/3 the radius of B, okay? And secondly, we are told in the question, if you look right at the top there, the ratio of B to C, radiuses that is 1 to 2. Yeah, and for those of you sort of write and complain, it's radii. Okay, so the radius of B is half the radius of C. And if we keep that one there, you could have written it like this, of course, but I'm using this one here. And that, replace the RB, the radius of B, in that equation for A. Right? So now basically we want to get rid of the radius of B. And so we have this statement: radius of A equals 5/3 the radius of C over 2. Right? So we're putting that in here. Okay, replacing the RB with RC over 2. And that tells us finally that the radius of A is 5/6 of radius of C. All right. God, try saying that in a rush. Okay, so that means the radius of A is a little smaller than the radius of C. Right. If you're not sure which way around the numbers go, if it's 5/6 of RC, then RA is smaller. So therefore we have that. Right, as the radius ratio. So RA to RC is 5 to 6. And the area ratio, remember I said, is a scale factor squared. So you square both. The area of sphere A to the area of sphere C is 25 to 36. All right. That is a genuinely tricky question. I think there's a lot of thinking and untangling numbers for only 3 marks. So, do pay attention to it, and particularly this thing here, very important. Okay, let's try and get this done in a couple of minutes here. In a village, right, and this one's going to take a little bit of patience. I'll go through it as quick as I can. It gives you some sort of probabilities that change depending on what happened before. Okay, if it rains on a particular day, then rain the next day is more likely, 0.8. Okay, and therefore no rain equals 0.2. If it doesn't rain on a particular day, then the next day the rain has a probability of 0.6. Therefore, no rain in this case is 0.4. Right? Okay. So we start off on a Monday. A forecaster says there's a 70% chance of rain. All right. And they want the possibility or probability indeed of rain on the Wednesday. So we have to go from a Monday, Tuesday to a Wednesday. All right. Now, if we want rain on a Wednesday, obviously Wednesday it's got to rain. But what happens the previous 2 days changes everything depending on what combination we have. So we're going to look at Monday, Tuesday, and Wednesday in all the possible combinations. But Wednesday has always got to be raining. Right? That's what we're actually looking for. Okay, so what I've done here is put in the different combinations. First one, I've put rain, rain, and rain. Okay, so Monday raining 0.7%, sorry, 70%, so 0.7, oops, 0.7. If it rains on Monday, remember the condition we had, that if it rains one day, the next day, the probability of rain is 0.8. So if it rains on Monday, probability of rain on Tuesday is 0.8. And then on Wednesday, as it's rained again on Tuesday, is also 0.8. All right. So rain on Monday and on Tuesday and on Wednesday. All right. Multiply all of those together and we get a probability for that combination of 0.448. Okay. Now change it to rain on Monday, no rain Tuesday, and rain on Wednesday. Same sort of thinking. Rain on Monday, 0.7. No rain on Tuesday would be 0.2 because it rained on Monday. And then if it doesn't rain on Tuesday, then rain on Wednesday is 0.6 probability. Again, multiply all of that and you get that. So you now get the picture, all right? Different combinations. And next one, no rain on Monday, rain on Tuesday, rain on Wednesday. And the one after that is no rain, and then rain on Wednesday. Okay. Remember that the chance of no rain on Monday is 0.3. All right. And the rest of it is as we have used before. So you get these 4 different ways, combinations of getting rain on Wednesday. Okay. And when you have something or something, you add the probabilities. All right. So therefore, your total 0.748. And as I've said before, if you have on this side something, and means times. Okay, multiply the probabilities if something and something happens. Add the probabilities if something or something can happen. All right, and therefore your final answer is as you see it. All right, and right, let's try and polish this thing off. A lot of words, time period, T seconds, simple pendulum. Don't worry, what that is. It's straight out of physics, and in fact, it's probably more A level. And there's a formula, all right? Katie used a simple pendulum in an experiment to find the estimate for the value of G. I think a lot of schools still do that experiment in physics. If you are doing physics to that level, you'll find that out. They got some results, all right? L equals 52, all right? And centimeters, right? Again, irrelevant, don't worry about all the units and things and whatever. To 3 significant figures, okay? And that means that L, right, rounds to 52.0, okay? So it could have been 52.05 is the upper limit of L, and the lower limit of L is 51.95, okay? Similarly, right, time, the time period, T is 1.45 correct to 3SF, okay, there. And that therefore could have been 1.455 down to 1.445 as the lower value. And that's the upper value there. All right. Okay, it says to work out the upper bound and the lower bound of G. All right. Right. The first thing to do is you need to get G on its own. All right. And rearrange. So first square both sides. Remember we had a square root there. Okay. So square both sides. Get rid of the square root. So you get T squared. And again, careful. You've got to square the 2 pi. It's not just 4 pi. It's 4 pi squared. Okay. So you just square everything on that. Right, and you end up with T squared equals 4 pi squared times L over G. Move the G to the other side, all right, and bring the T squared underneath as a divisor, denominator. And you end up with this formula here. All right, that's the rearranged G on its own. Okay, the upper limit of g is going to be 4 pi squared, the upper limit of L over the lower value of time, or time period as you put it, squared, all right? So the upper bound of L over the lower bound of the time period squared, okay, in order to get the maximum value. And if you work that out, we put the numbers in there, 52.05 divided by 1.445 squared. Okay, there we go. And don't forget the 4 pi squared, and you get that. All right. On the other side, you want the lower value of L, all right? So that's the lower value of L, over the upper value of T squared, all right? So effectively, that gives you the minimum, right? You've got the smallest value possible divided by the biggest possible value, and that gives you a minimum, right? So that will be the lower bound of G, and 51.95 over 1.455 squared, and again the 4 pi squared, you get your 969.018, all right? To 3SF is probably the limit here, because that's what the rest of the question was in. And that gives you 984 and 969. All right, there we go. Okay, I've managed to shave almost, 15 minutes, 20 minutes off that. Still a bit slower than I wished. Anyway, if you have watched this far and you're still awake, thank you very much for your patience. I hope it's helped. Do go over any questions that, were trickier. And if you did find it useful, then, as I said, please do consider subscribing and switching on the notifications, as I will be doing more papers and launching other science videos and maths videos as well. All right. Any comments you have to make the videos better, if any way I can improve them, please do help out with any advice or comments and suggestions. Always welcome. Thank you very much, and best of luck with your exams.